So we got our answers from yesterday. I think I'm gonna try and figure out how to make them like into like a little PDF file and then just post them on the lesson plan. So I'm working on that. I think that might be a little easier than showing it up here every morning. Agreed? Oops. Yes. Which one? 5? I'll put it on the list. You guys good with these ones? You good? All right. So I got a couple questions on a couple of them. So let's go through them. So number 5, we have the square root of negative 36. Okay. So when we're taking square roots, we're doing the reverse of squaring something, right? So we're looking for a number times a number, and it's got to be the same number that's going to give us 36. So what could we multiply, or what could we square that's going to give us negative 36? Because if we did 6 and 6, that's going to give us a positive 36, right? If we did negative 6 times negative 6, that's going to give us a positive 36. So there's no way you can multiply two numbers together that are exactly the same and you get a negative, right? So these are those imaginary numbers that we'll talk about in the near future, right? So like right now, either no real number because it's imaginary, it's not real, or you can just say it's undefined. And then we had 17, which is the square root of 2x times the square root of 6x. So the way that they are right now under the radical sign, we can't simplify them any farther, but we can put these two together, right? This is the same thing as the square root of 2x times 6x. So that would be 12x squared. And then now we can separate them. So now I can separate it into negative, or 12, square root of 12, and the square root of x squared. And then on 12, we can break 12 down. That's looking through our perfect squares. That would be the square root of 4 times the square root of 3. Square root of 4 is going to give us 2. Square root of 3, we can't break that down any farther. And then the square root of x squared would be x, right? Because x times x gets us to x squared. So I just start with my whole numbers, my variables, and then I put those square roots at the end. And then 31. So 31 is the square root of 200x to the third all over the square root of 10x to the negative 1, right? So I know I can't do anything like with the denominator, like simplifying it the way that it is. So I'm just going to take the whole thing and write it all under one radical, right? And then I'm going to try and simplify it. I'm going to go number by numbers and variables by variables. So if I just look at my, like the 200 over 10, what's 200 divided by 10? 20, right? And then I'm going to look at my x's. So I'm going to use the quotient property because they're dividing, so we're going to subtract them. So you would have x to the third minus negative 1, which would give you x to the fourth, right? You picking up on what I'm laying down? So then now I can break these apart. So if I look at square root, well, I can do square root of 20, square root of x to the fourth. Square root of 20 is going to give me the square root of 4 times the square root of 5. And then either from here, you can sit there and go, you know, what squared or what times what's going to get me to x to the fourth, or we can break it into x squared and x squared. But do we all agree that x squared squared would give us x to the fourth? So we can't break that one down any farther. Square root of 5 isn't going to go anywhere. Square root of 4 is going to give me 2. So 2x squared square root of 5. You got any other ones? Yes. 29. So the square root of 150x to the fourth all over the square root of 3x, right? So again, on these ones, I'm going to go ahead and throw it all under one radical expression. So 150x to the fourth over 3x. And then I'm going to simplify each one of those, right? I'm going to look at my numbers. So 150 divided by 3 is going to give me 50. Right? And then I'm going to look at my x's. So that's going to give me x to the third. Yep. So then I got square root of 50, square root of x to the third. Anybody know how we can break down square root of 50? Square root of 25 times the square root of 2. Right? And then are there any things that we can multiply that give us perfect squares for square root of 3? That'd be the square root of x squared times the square root of x. So then we're just going to go piece by piece, right? Square root of 25 is going to give us 5. Square root of 2, can we break square root of 2 down? Nope, so that one's done. The square root of x squared, that's going to give us x. And then can we simplify square root of x any? That's as far as that one's going to go. So I'm just going to start with, right, so 5x. And then if you guys want, if it makes you feel warm and fuzzy, you can write it as the square root of 2 times the square root of x. But because they're all, those two are under the radical, you can write it as 5x square root of 2x. You can just go ahead and multiply those together. So either one of these is fine. Any other ones? Are you guys starting to think radically? Tough crowd, tough crowd. All right. So we just got to finish up our little P3 and kind of just look at a couple more little radicals, look at some third roots, fourth roots, fifth roots type of thing. And then all radicals can be written as a fraction, which is really kind of nice, I think. I like it better sometimes. But, and then tomorrow, it's just going to be like a review day, so it's not going to be anything new. We'll go over these answers. I got to get you guys signed into like Go Guardian so that on Monday we can have our little quiz. So the quiz will be over P2 and P3. And it won't be very long, I promise. Especially with it being the first one, and I'm going to be apprehensive that we might have some technology issues, so it'll be a easy one. Sound like a plan? Excited? I'd be excited. All right, you guys ready to hammer these out today? So we got our little P3B. So we're going to look at rational exponents. We're going to start by looking at some other roots, but then we're going to get into looking at them written as with exponents in them. So there are other roots. I know we've been looking at square roots, but I think there might be some circle roots, some triangle roots. I'm really trying here, guys. You guys are... All right. So there are the third roots. Right? So if we took the, you know how like this would have been the square root? We just never put that little 2 in there when we talk about square roots, because we just call that little symbol a square root. But we have other roots besides just square roots. So we can actually take the third root of something. So you're just going to put like a little 3 in the little radical symbol. So now if I'm looking at third roots, so square roots was a number times a number, right? So if I'm looking for third roots, I'm looking for a number times a number times a number, right? So now I'm going to multiply the same number together 3 times, or to the third root to get my answer. So what times what times what's going to give us 1? 1. Good one. That's the hard one, right? What if I took the third root of 8? So I'm looking for a number times a number times a number. 2. You guys seeing the pattern here? If I took the third root of 27, what's the third root of 27? 3, right? 3 times 3 is 9, times 3 is 27. What's the third root of 64? 4, right? 4 times 4 is 16. And then I usually cheat and, then 16 times 4 is going to give me 34 or 64, right? So these numbers start growing pretty good. Right? What do you guys think the third root of 125 is going to be? 5, right? And we can keep going with these. We can do fourth roots. The fourth root of 1 is going to be 1. The fourth root of 16 is going to be 2, right? 2 times 2 is 4. Then I just do 2 times 2 is 4. 4 times 4 is 16, right? What would it be for 3? What would be under the radical if I wanted my answer to be 3? Oops, thanks. There we go. How about the 4? Whoops, now I'm giving you the answer. All right, so the fourth root of 81 is 3, right? 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. What if we took the fourth root of something and we wanted it to be 4? 256, right? So these ones start growing pretty quick. And then we can even do 5. I'm on a roll now. What's the fifth root of 1? 1. The fifth root of 32 is 2. The fifth root of, what would it be, 243 is going to be 3. So once our root number starts going up, like the part under that radicand, that's going to start going up too, right? All right. So we can do the same thing that we did yesterday. We can do all of that same stuff with numbers that have different or higher roots on them. So if we try to find, let's say, the third root, whoops, oh my. The third root of -8. Would it be what? Well, so on this one, because we got the third root, so we're trying to find a number times a number times a number that gives us -8. So it's got something to do with 2, right? 2 times 2 is 4 times 2 is 8. Could I have a negative 2? Negative 2 times negative 2 is 4 times negative 2 is negative 8. So if we're taking the third root of something, we can have negatives, right? So this is going to give us to negative 2. Right? And you can always, remember when you guys used to check your work? So to check it, I would have negative 2 to the third. Oops. So negative 2 times negative 2 times negative 2 is going to equal negative 8. So if our root, if our root is even, so if it's 2, 4, 6, 8, who do we, yeah. If it's even, then we can't have any negative numbers for our answers, right? Because if it's even, you're multiplying even numbers together, you're either going to have odds and or negatives and negatives or positives and positives, so your answer is always going to be positive. But if your root is an odd number, you could have either or. You could have positives or negatives. Because if I just asked you guys the third root of 8, what do we know that the third root of 8 is? It's 2, right? But since this is an odd number, we can actually have a negative under that root because it's not a square root, it's an odd root because it's 3. Not too shabs? All right. One more. Oh, you want to do one more of these? Maybe. What if we had the third root of 24? If we go back to our third roots, do we have any perfect 24s under there? No. But do any of these divide evenly into 24? Is this one? So we can, just like when it came to us doing square roots, we can break this down into our perfect cubes. So we know we have the third root of 8 times the third root of 3, right? 8 times 3 is going to give us 24. Can we simplify the third root of 8? That would be 2. Can we simplify the third root of 3? Do we know a number times a number times a number that's going to give us 3? Nope. So then that one. So then our final answer would be 2, and then the third root of 3. You guys good? All right. So let's talk about these little guys as exponents real quick, and then I'll let you be. So let's talk about rational exponents. So technically, like if we have the square root of 4, technically there's like a little 2 there, right? We're actually taking the second root of it. We just don't ever put the little 2 there when we're talking about square roots. So we can write any radical expression. We can write it as a radical sign, or we can write it as the exponent being a fraction. So if you have some number, and we're going to say that it's raised to the m over n, that's the same thing as having that radical sign. Your a is going to be the radicand. Whatever is your m is the exponent on your a, and you're taking the nth root. So technically on our little 4 here, there's technically a little 1 exponent on there, although we don't really see it. So this one would be 4 raised to the 1/2. So you can either write it as 4 to the 1/2, or you can write that as the square root of 4. So especially when it comes to square roots, when I'm working on calculators, instead of trying to hunt and find that square root button, more times than none, when I put it in the calculator, if I have to find like the square root of 4, I put it in the calculator. I do like the 4, and then I do the caret, and I do 0.5. Because to me, like putting this in the calculator is easier than trying to find that little square root button and then pushing the 4. Because I can never find that guy. I don't know where he is. Sound good? All right, let's try a handful of these. So let's say we had 64 to the 1/2. Right? So we know we're going to have a radical symbol because it's a fraction. My radicand is going to be the 64. My numerator goes there, so that's technically a 1 if we want to throw it in there. And my denominator is my root. Right? So I'm taking the square root of 64, which is going to be 8. Right? What if we had 125 raised to the 1/3? Because it's a fraction, we know it's going to be some kind of radical. Right? My radicand is going to be that 125. What's going above the 125? What's the exponent on 125? 1. And what's the root I'm taking? Taking the 3rd root. So what's the 3rd root of 125? 5. I think you guys need some fancy ones. What if I had, whoops, I need to go back. Sorry guys, I apologize. Your little m, whoop. We need to throw the whole thing in parentheses and put our m out there. It's easier if we just learn it that way, yeah. One of these days. So let's say we had 27 to the 2/3. So because it's a fraction, I know it's going to give me a radical sign. I know my radicand is going to be 27. That's all going to be raised to the 2. And I'm taking the 3rd root. So by orders of operation, I got to do my parentheses first. Can I simplify the 3rd root of 27? Yes, Mrs. Fitch, that would be 3. Good job, yeah. And then I still have my squared. And 3 squared is going to give me 9. What if it was a negative exponent? What if we had 81 raised to the negative 3/4? So first thing we gotta do is take care of the negative. So that's gonna give us 1 over 81 to the 3/4. So then now we get 1 over, we know that's gonna be some kind of root with 81. We gotta take the whole thing to the 3rd power, and we gotta do the 4th root. Anybody know what the 4th root of 81 is? It's a little bit bigger than 2, but less than 4. So 3. And then we still have our 3rd. So that's gonna give us what, 1 over 27? So you technically can put these into your calculator. I need to have fraction answers, but you probably know how to switch our calculators into, so it gives us fraction answers too. So you can always check them that way. All right, I'll try a couple problems. You guys got any questions? Let's do. So I believe, or no, I think it's 2 weeks. 2 weeks you guys have picture day, but do you know what kind of photos do teeth take? Anybody? Toothpicks. That's the kind of photo teeth take. I should have done it with the microphone. It would have sounded better, wouldn't it? Man. All right.